Dude, I can't believe that happened. Like, what the heck? I don't even know. It's crazy. You know, like, how could that have happened?
Yep. I'm trying to do my work.
Sorry, man. Sorry.
You know, I don't understand this math homework at all.
See what you're doing.
Conics. Like, what's conics? Conics sections? What's conics?
I don't know, dude. I heard, like, you know, this one guy who was an architect talking about how he used conics to build buildings.
Oh, yeah. My teacher was telling me there's, like, parabolas, circles, hyperbolas, and ellipses.
But, you know, I'm not really sure, like, what they mean, like, the equations or how I can use them in my real life.
What type of jobs use conics? Architect.
I feel like
how
conics.
Cakes made.
Yeah, like how I feel like there's conics in like everyday things that we don't even realize.
How like profession? Yeah, like in a ton of different professions, like architect or building interior design or 3D animation
or doing like aerospace design, creating an airplane. You know, like
being an engineer. Wow.
We have to research this.
We should do that. There are 4 main parts of conics.
Hello class, welcome to math class. Today we'll be learning about conics. Tommy, what are some examples of conics in professions?
I don't know.
What about me?
A math teacher?
Correct.
Yay.
Now we shall be going over other professions that use conics. One of the most basic conic sections is the circle. There are 2 different equations for the circle. The first one is x squared plus y squared equals r squared. In this equation, the center would be 0, 0. The other equation is x minus h squared plus y minus k squared equals r squared. And in this case, the center would be h and k. You also have to remember that if one of them is negative or positive, you flip it around because they're the opposite. An example of this would be x squared plus y squared equals 9. To graph this, first we have to recognize that this is the first equation, so the center is going to be 0, 0. We're taking the square root of 9, which is 3, and we're applying it to every single side of the circle. So right here we have 3, 3, 3, 3. As you can see, this makes a perfect circle if you're a better drawer than me. For the more complex equation right here, we have an example that is x minus 3 squared plus y plus 7 squared equals 25. The first step in solving this equation is taking the square root of 25, which equals 5. The next step is finding the center of the circle, which is 3, negative 7, as we can tell from the h and k points. We're going to graph that now. 1, 2, 3, negative 7. This right here is the center of our circle. Now we're going to take this 5 and we're going to apply it to the circle by making it go out 5 points to the right, the left, up, and down. Here we have a circle, again poorly drawn.
The next part of conic sections is an ellipse. There are 2 equations. One is x squared over a squared plus y squared over b squared equals 1. The next equation is x minus h squared divided by a squared plus y minus k squared over b squared equals 1. An example of how to use this first problem is this problem over here. X squared over 4 plus y squared over 9 equals 1. To graph this, you take the square root of 4, which is 2, so you 2 right here, and negative 2, and the square root of 9, which is 3, and this is negative 3. You graph it as a circle, but it's going to be look more as an oval, since it's an ellipse. Another example of the ellipse equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. In order to graph this, here's an example. X minus 1 squared over 16 plus y plus 5 squared over 9 equals 1. First, to graph this, we need to change the sign. So if it's negative 1, it's going to be positive 1 and down 5. So it'll be 1, negative 5. So this is the midpoint of the ellipse. Next, it'd be 16. So we'd take the square root of 16, which is 4, so out 4. And then 9, the square root of 9 is 3, so we'd go up 3 on both sides. And then we'd draw the ellipse like that. And the midpoint would be at 1, -5.
So tired. You know what? All this hard work makes me hungry.
Yeah, and you know what else? I could really just sit down and relax.
And watch Cake Boss.
We should also bake cookies using shapes and circles and ellipses.
Oh my god. Such a great idea. Let's go do it.
'Tis time to make the cookies. As you can see here, we will take this ingredients and we will make it. All these ingredients. We will graph it out on this graph piece of paper. As you can see, this is our cookie plan.
Conic section is a parabola. There are two equations for a parabola. The first one is y equals parentheses 1 over 4p and the parentheses x squared. The second one is y equals 1 over 4p parentheses x minus h and the parentheses plus k. I'm going to use this first equation to show you how to graph a parabola first. If we come over to our graph, we have an equation right here that's 16 equals 1 over 4p parentheses 4 squared. So what's happening right here is 4 squared is 16. 16 equals 16, so what does this have to be to make 16 equal 16? Well, after doing math, we figured out that it was 1/4. So first, after we placed our vertex at 0, 0, we knew that the focus was 0, 1/4 away from the vertex, and the directrix was also the same length away from the vertex. Next, we took the x and y numbers in here, and we merely plugged them in. So 4 is x, 16 is y, and that was how we were able to graph the focus, the directrix, and the 2 points.
There are 3 equations for hyperbolas. One is x squared over a squared minus y squared over b squared equals 1. For this equation, the center would be 0, 0. And for number 2, the equation is x minus h squared over a squared minus y minus k squared over b squared equals 1. And lastly, x minus k squared over a squared minus y minus h squared over b squared equals 1. Some examples of hyperbole is this one. Using the first equation, y squared over 25 minus x squared over 36 equals 1. To solve this equation, I plugged 6 in for y, so I got 6 squared over 25 minus x squared over 36 equals 1. And then you come over here, and this gives me 36 by squaring 6x over 25 minus x squared over 36 equals to 1. So then this would give me to 1.44 minus x squared over 36 equals 1. X squared would give me 34.56, and x would equal around 5.87. To graph it, I would start off by graphing a box of 6 for this part, 6 in length and 25 in width by taking the square root of 25 and taking the square root of 36. The focus will be down 2 and up 2. And then I'd plug in 5, or use this by doing 6, 5.78 as the point, and same with here on the opposite side to create the hyperbola. And I do this for both sides down here to graph my hyperbola. And this is just guesstimating, but this is around what the hyperbola would look like for this exact equation. Another profession that uses conics is car manufacturer. In this profession, I use the lights. Anyways, I use lights and I drill a hole into them. Just kidding. I don't do that. But anyways, to fix the light, as you can see here, the ray in the back is directed from the parabola at the focus, which is in the front. Back here is the directrix, and up here is the vertex, where it is equal to the focus, which is up here. And there's even space between the directrix and the focus from the vertex. As you can see, it's a parabola shape. If you look straight into the light, as right there, or here's another example right here, it kind of creates a bowl shape, which is where the light reflects off.
Another profession that uses conics are engineers. For example, I'm a bike engineer, which means I graph out bikes and how they're going to be created before they're even made. An example would be the specialized frame. As you can see, this part of the frame is slightly bent. And this could have, the way I made this was I graphed a hyperbola using our equations, and I made restrictions so that there was only a certain part of the hyperbola that was made, which created this bent, more aerodynamic part. Another important part of bicycling is the wheel and tire size. There's a lot of new conversation about how wheel and tire size affects the ride. So I graph out tire sizes and wheel sizes on a graph, and I test them out. And that is how engineers use conics. The profession that uses conics is sports, like basketball. What's up now, Rep, huh?
That was not correct.
We got you going.
Actually, were you using the correct parabola and equations to do that?
Whatever, man, I just play the sport. I don't care about this man.
Right here. You need to roll the ball so that a parabola goes up and over with the correct amount of length, and so that the focus is straight down.
Whatever, man, I just play the
that?
ball.
That
I
means
just play.
Alright, do it again. See? Wrong.
You show me what you're on sport, bro.
Fine. Soccer is another profession that is used when graphing or playing with conics and mathematics.
One. So tell me, how can you use conics to make your sports better?
You see, soccer is a very complex sport. It takes a lot of knowledge and power to get the correct angle and the goal. So the goal is box, you see. And when it's far away, and you have to kick it in the right angle. You must kick the ball with the right parabola so that it goes up and goes down. So that, you could even graph it. If you were to go in slow motion, you were to be able to graph the soccer ball as you kick it.
Man, Natalie, that sure was a great kick.
Thanks. It took a lot of brain power.
We sure learned a lot about conics in this presentation.
And a ton of professions, too.
And now you can.
Aubrey and Natalie are going to pass out some sheets while you guys enjoy our dancing.
Go along.
Go on,
Come on, Abra.
Come
Pass it out.
Go, Natalie.
Let's go.
Go, Aubrey.
Come on.
Come on.
Sweat shop coming through, so everybody move over. Don't sir, don't worry at all. We're gonna break the mold and shake the whole thing so surely they'll fall. So everybody move over.
No sir, don't worry at all. We're gonna break the mold and shake the whole thing so surely they'll fall.
What?
Please give it to me.
What?
Please. Get my phone.
Hold on.
That was an excellent kick, Natalie.
Thank you. It really took some brain power.
Did you stop it? We can't do this. Man.
We'll just wait it out.
We're good.
Like the
Ready?
dinner we
3.
did at your dad's house.
My dad's house? So my mom and my dad don't live together anymore? We can just stop this. Okay, ready? Man, Natalie, that sure was an excellent kick. You know?
When do we go?
Whenever we want, whenever we feel ready. I'm not ready yet.
Do you just know it?
I know I'll know when I'm ready. Great kick.
Thanks.
Okay, 3, 2. Man, look at you.
Do it again.
Basketball player, bro.
Tell me what you're doing.
Yo, I'm pumping up the basketball so I can, like throw it in. Video. Yo, basketball, bro. That's what I'm doing. Pumping up the ball so that it can be ready to be thrown around and all that stuff. Just gonna pull like that.
Throw it around, like what kind of
shoot,
throw it
I'm
around?
losing air.